It's our 80th anniversary. Mahalo to our Big Island community for your continued support and for trusting us with your financial needs.
With 75,000 acres of Hawaii Island Ōhiʻa forest now showing symptoms of the fungal disease known as rapid Ōhiʻa death, federal and state agencies and nonprofit partners are using an array of high technology to detect its spread. The battle against the two types of ceratocystis fungus that causes rapid Ōhiʻa death has always been a hugely collaborative effort. The collaboration between the agencies and organizations engaged in the fight against this devastating disease not only continues, but is expanding, particularly on the detection front.
At our positive control.
So we have a whole plethora of different organizations helping us, especially detect the fungus. Early detection is really important, especially to protect the other islands where the fungus has not been found yet.
And to provide data and scientific information to aid researchers working hard to find a way to stop it. Researchers show 3 of the high-tech survey detection tools currently involved in mapping and on-site testing for the presence of rapid Ōhiʻa death.
It certainly helps prioritize which areas to focus on, which trees to focus on. If we are pulling samples out and we're getting a lot of positive results, then obviously that's an area that we want to focus our attention on.
Dr. Carter Atkinson, a research microbiologist with the U.S. Geological Survey based at Hawaii Volcanoes National Park, developed what the team from the Big Island Invasive Species Committee, or BISC, fondly calls a lab in a suitcase.
We'll give them 5 minutes.
Prior to the development, earlier this year, of Atkinson's portable testing laboratory, all samples were sent to the USDA ARS Daniel K. Inouye U.S. Pacific Basin Agricultural Research Center in Hilo.
Well, the lab in a suitcase has been really nice because we can take the samples and then within a couple of hours we can have results, preliminary results from the samples, which makes it really beneficial because if, say, for example, we were to find something positive in a remote location and we're still out there, then we can immediately go out and do more samples so we can get a better sense of how widespread this possible infestation is. We can also get these results and we could make management actions right straight off.
Actually, Rose, you have a spare hand?
Yep.
Can you undo the bottom cover?
Yep.
Another team of researchers prepares to launch an unmanned aerial system, or UAS, off the side of Steinbach Road, one of the epicenters of the infection. Dr. Ryan Peroy of the Department of Geography and Environmental Science at UH Hilo and his team are now spending about a quarter of their time flying the UAS for rapid Ōhiʻa death mapping and detection.
Yeah, let's let this car go and then...
So for rapid Ōhiʻa death specifically, we've been using drones for about 1.5 years for monitoring changes in the forest on an individual tree basis, which is sort of new that you can do with drones because the resolution of the imagery is so fine that you can see individual leaves and branches and things. And we've also started to be collecting data not only to see changes over areas already affected with rapid Ōhiʻa death, but when there are suspected cases of new cases, the state or others will call us to come out and fly the area and see if we can determine from the imagery, is it just an individual isolated tree or are there more trees in the surrounding area?
Above at 8,000 feet, the Carnegie Airborne Observatory is in the process of remapping roughly 650,000 acres of Ōhiʻa forest on Hawaii Island. This is the second time this twin-engine aircraft with millions of dollars of highly sophisticated equipment on board has peered into the very structural makeup and chemistry of individual trees to measure forest health. The first time was in January 2016. This month's flights will provide additional 3D imaging and data to fuse with ground data and the UAS data to give scientists and resource managers a really clear picture of the scope of spread of rapid Ōhiʻa death.
But we're really tuned to do is map the health and condition of every tree in the forest as we pass over it. Our imaging system is 3D. That means we see the leaves in the canopy and the height, the structure of each tree. And then another part of our technology sees the chemistry in the tree canopy. The kinds of chemicals that we map are nitrogen concentration in the leaves, water content, sugars and starches, the building blocks of the tree.
The Carnegie work provides the whole island view, and that interfaces with all the field work and with some of the high-resolution mapping that's happening locally within some of the canopies. It gives the big picture, landscape scale view, but also with a lot of detail. All of the researchers and managers working to combat rapid Ōhiʻa death agree that their collaborative efforts are about the only silver lining to what is a serious threat to Hawaii's most important native tree.
I think that this experience, seeing how dedicated all these partners are and how well their collaboration went, supported by the top-notch technology that was deployed for this, really made everybody aware of how valuable collaborating, meeting, and communicating is.